Hello everyone, I am Varun and our next topic is KNN, K nearest neighbor, and it is one of the simplest and most intuitive supervised machine learning algorithm. It is widely used for classification and regression problems. The idea behind KNN is very simple. Data point is classified on based on how its nearest neighbors are classified, and KNN does not build a transitional model. Instead, it stores the training data and makes prediction only when required. And this is the diagram explaining this. First, we take the initial data and calculate distance and find the neighbor and voting for labels. How KNN works: choosing the value of k and calculate the distance between the new data points and all training points. Select the k closest data point, take a majority vote or average, assign the predicted output, and it is the distance formula. Extend to new data points, smaller distance to more distance data. KNN calculates the distance for all points, selects k nearest and then predicts the class. And distance matrices used in KNN. Euclidean distance is defined as the straight line distance between 2 points in a plane of space. You can think of it like the shortest path you would walk if you go to directly from one point to another, and its formula is this. And under root summation of I equal to j equal to 1 to d xj minus xij of whole square bracket close. And Manhattan distance, this is the total distance you would travel if you could move only along horizontal and vertical lines like a grid or city streets. It's also called taxi cab distance because a taxi can only drive along the grid like streets of a city. And it is the formula d of x comma y equals summation of I equal to 1 and mod of xi minus yi. Minkowski distance is the family of distance which includes both Euclidean and Manhattan distance as special cases. And xy equal to bracket of whole summation of I equal to 1 to n x of I minus y of I to the power p, the whole bracket to the power 1 upon p. And Hamming distance for categorical data, choosing the right value of k. Small k example, k equal to 1 sensitive to noise, large k more stable but may reduce accuracy. Best practice, use odd values to avoid ties and try different k values. Simple example, dog versus not dog classification. We want to predict whether an image contains a dog or not dog based on features like and here we have used a simple and short code for this example. We are importing the required libraries from sklearn neighbor. Import k neighbor classifier from means from sklearn neighbor we are generating or creating the import we are creating or generating the k neighbor and x equal to 10 20 comma 15 25 30 40 35 and 45. It is the input features or variables, and y is dog not dog. It is the output data labels, value labels. And KNN equal to k neighbor classifier and underscore neighbor equal to 3 means we are here the model is generated or created with k equal to 3. And KNN dot fit x comma y means the model is trained to store memory data, and here is the output. And result equal to KNN dot print, it has predicted the value 1222 and print, and we are printing the result, and here is the output. And conclusion, the detailed KNN code clearly demonstrates how distance based learning works even without complex math. KNN efficiently classifies data using similarity, making it one of the best beginner friendly machine learning algorithms.